Hello, my name is Claire, and this is my presentation on Deyo's Charlson's Index. So some background on the Deyo-Charlson's Index. What it does is it categorizes the comorbidities of patients using ICD diagnosis codes. In 1987, the Charlson Index was developed by Mary Charlson, and it had 17 categories, and the list of diagnosis codes were modified. And then in 1992, the Deyo-Charlson Index was developed. Richard Deyo actually developed a modified version of the Charlson Index. This one actually consisted of 19 categories, and this was used to predict the risk of death within 1 year of hospitalization with specific conditions. Then in 1993, the Romano Index was developed. This is by Patrick Romano. Both the diagnosis codes and original weights used for the index were modified, and this best predicted mortality rates. So an example of the usage of the index, in 2010, the French National Health Insurance Database used the Charlson Comorbidity Index to predict a 1-year mortality of discharged patients. And this was the first study to adapt the Charlson Index into such a large healthcare database with over 6 million patients. What this study did, it used the ICD codes of the diagnoses of discharged patients and ran through the Charlson Index, and it concluded that over 6 million subjects were discharged from medical, surgical, or the obstetrical department, and the 1-year survival rate was 94.88%, and was concluded that measuring the mortality rate, the use of the age-adjusted Charlson Index is recommended as a level 4 score. For the cleaning of the data, you'll want to remove any nulls and anyone diagnosed after their death, and use the cleaning codes as shown here on the left. And after you clean it, you should get a number of records used in the analysis to be 17,431,402, and the number of patients being 829,625. As for the scoring of the index, each category is assigned to its own weight value based on the ICD-9 codes, and then the patient is calculated into a score based on whatever category they fall into or condition. So here you can see the different conditions in the categories they fall into based on the ICD-9 codes. For the accuracy of the index, compared to the gray line shown in the graph, the gray line is actually what the curve would look like if you were to predict the changes randomly. And so you want to find the area under the curve of the blue line. The closer the area under the curve is to 1, the more accurate it is, and the area under the curve here is actually 0.6179, so that would be closer to 1, so it would be somewhat accurate. To improve the accuracy of the index, 2 things you can do is A, utilize improved cutoff values, and B, updating the score weight of every diagnosis. And here are the references I used in my PowerPoint. Thank you.